Look at the sheer mechanical force here. Every muscle contraction, every drop of sweat represents an engine burning fuel at the absolute limit. To track that effort, we have strapped sensors to every wrist and chest, obsessively watching a single metric, beats per minute. But a heart rate monitor is ultimately a speedometer. It tells you exactly how fast the engine is turning over, but it provides zero information about the type of fuel that engine is actually burning. The true goal of endurance training is finding the exact chemical thresholds inside that engine. You need to identify the exact moment the body stops burning fat efficiently, the aerobic threshold, or LT1, and the moment it begins accumulating lactate, the anaerobic threshold, LT2. Because beats per minute is a blunt aggregate average of your pulse, a standard heart rate monitor is completely blind to these individual metabolic shifts. For decades, mapping those exact physiological thresholds meant stepping onto a treadmill in a sports science laboratory and stopping every few minutes to draw blood and measure the lactate concentration. That clinical precision comes with massive friction. It requires a technician, mid-run needle pricks, and lab tests that run anywhere from $200 to $500 per session. Consumer wearables attempt to estimate these thresholds to avoid the lab entirely, but they rely on generalized population averages rather than your individual biology. Athletes are caught between two extremes. You either pay for static, expensive lab accuracy, or you settle for dynamic, free guesswork. To find a more precise path, we have to stop counting the quantity of heartbeats and start looking at the microscopic space between them, the heart rate variability. This chart compares two rhythms. A perfectly rigid, metronomic heartbeat is actually a sign of stress. In a healthy, resting body, the timing between beats is highly chaotic and mathematically complex. Watch what happens to the nervous system when an athlete pushes into hard effort. The autonomic nervous system shifts control away from the calm parasympathetic state and activates a sympathetic fight-or-flight response. As that fight-or-flight system takes over, the space between the heartbeats loses its healthy chaos. The interval rhythm becomes structurally rigid and highly correlated. The body's hidden metabolic shifts are constantly broadcasting their status, not in the heart rate itself, but in the fractal degradation of the heartbeat rhythm. To measure that structural degradation, scientists use a specific fractal mathematics formula called detrended fluctuation analysis alpha-1. This vertical scale shows how clinical researchers mapped the formula as biological markers for blood lactate thresholds. When the math hits exactly 0.75, the body crosses LT1, shifting out of peak fat oxidation. Dropping below 0.50, it crosses LT2, and rapid fatigue accumulation begins. The engineering hurdle with this math is computing it in real time. It requires massive computing power to filter out the physical motion artifacts created by a running athlete's foot strikes. The neurometric HRV Alpha app solves this using a specialized matrix algorithm called a smoothness priors filter. It instantly cleans the raw interval data transmitted from a standard $60 Bluetooth chest strap. By combining consumer sensors with complex matrix detrending, the $500 blood lab process has been digitized and placed into the athlete's pocket. We usually assume that cardiovascular fitness is defined entirely by how long an athlete can sustain high-intensity effort. Under Dr. Joe's proprietary push-pause methodology, the most valuable clinical data is actually gathered in the exact moments following the sprint. Look at how a high-performance brake system operates. Its capability lies in absorbing and dissipating massive amounts of kinetic energy in a matter of seconds. The human parasympathetic nervous system functions exactly the same way. High-level fitness is defined by the bandwidth to rapidly accelerate and then rapidly decelerate. This graph maps that exact deceleration. The app captures the speed at which the heart rate plummets from its highest peak down to its lowest trough, calculating a precise deceleration slope. That precise slope is the ultimate indicator of cardiovascular efficiency. It reveals exactly how fast your nervous system can clear physiological stress. This deceleration speed forms your vagal fitness fingerprint. It is a deeply personal biological signature that generalized wearables simply cannot calculate. Complex clinical theory, real-time fractal mathematics, and laboratory-grade accuracy now live in a simple, color-coded Android application. Endurance training is no longer about blindly pushing into the red. By reading the hidden mathematical language of the heartbeat, athletes can identify their exact physiological thresholds during every session.